Marius Wichtner is a freelance software engineer based in Germany. He consults with KiloClaw on running multiple coding agents in parallel. It's an open source agentic engineering platform used by over 1 million developers. Before going independent, he was a lead software engineer at MaibornWolff, leading agentic AI and agentic coding work for enterprise customers. What makes him the right person for today's topic is the combination. A production engineer first, an AI practitioner second. Someone who has seen agentic systems both at open source scale and inside real enterprise code bases. His talk, Who Reviews the Agent? From IDE systems to OpenClaw. Please welcome Marius Wichtner.
Yeah, thank you so much for the introduction. First, I want to start off with a couple of questions because we just had lunch, everybody. So I want to first ask who actually ships code and reviews code into production. So nearly 80%. And who of you is considering yourself a team lead or like leader of a team? Okay, like roughly 40, 30%. I think I'll come back to this slide later, but what I want to talk about today is exactly the domain of reviewing, and I've heard a couple of conversations on this conference already about exactly that. How do you review all of the PRs? Like, how do you get a handle of what actually happens? And specifically, I want to talk about intent today. And that's why I'm asking who reviews the agent today. And I'm hoping till the end of this talk, I'm going to answer this. So who is Kilo? Who am I? I got introduced. Thanks again for the introduction. But I'm part of the technical stuff at Kilo. So what we do is we come from an agentic coding background. And our company, like many of the model labs, they're very agentic. So that differs a little bit from maybe customers, what you're used to, or I used to be, where you have many constraints on the client side and many dependencies in communication. Whereas all of these agentic companies, they just start an agent for everybody, for everything, what they want to do. And Kilo is an open source platform. We do agentic coding in different directions. Our primary product sits in the VS Code extension right now, but we also work for develop extensions for JetBrains, for CLI, for different things. But I'm not here today to make a product presentation today, so don't fear that. I'm trying to take Kilo as an example in how you actually can use an agentic coding harness to review and get code shipped quickly. We also have a couple of users and a couple of tokens, but yeah, so I think the bottleneck in software engineering, what you probably all noticed in the last couple of months, has shifted a little bit. We are shifting from how do we develop actually software to what do we actually develop. And you might have noticed that this gets more tedious and more exhausting. Like you will have your manager maybe telling you should use a team of agents and like start all of those agents in the cloud, and wherever you can use an agent for the task. But maybe you should think about also like what do we actually use those agents for? Like in what direction do we want to go? And it becomes more and more important the less you have attention and the more agents you get. So in today's talk, I want to talk a little bit about like what do you actually should ship and how do you do it? So you see here, I think the font is a little bit not so visible, but you see here mission control, and mission control is actually a good example of what we're moving into right now. We're starting all of those coding agents, and then we kind of go in YOLO mode and auto-approve or whatever, and then at some point the agent comes back with some task. But there might be a point where you actually should look into where we're going, in what direction we should go. And exactly that is also mission control in some way representing. So it's still important to actually understand the mission and where you're going. And because you are the person that actually knows the product or that knows your users, I think the intent is one of the most important examples for this. So as this trend is now coming, and you see all of those slides from the model companies that we only need the model anymore and we don't need anything else. You'll notice that the industry has a little bit changed. So there's a lot of security incidents, and if you work for an open source project, I'm not sure if does anybody work for an open source project, contribute to open source? Okay, so roughly 5% in my guess. Open source contributors and maintainers, they're getting angry. They're getting angry at all of those people starting slop PRs. And this is why, for instance, curl and also Ghosty and the bigger project, they stopped actually even accepting AI contributions at all. They even have a mechanism that sees if the PR you created hasn't been created with a description in the first request and then was added in the second request, they automatically think that you're an AI agent because no human would ever do this and then block you and ban you from the project. So there are a couple of contributors now, and I want to share with you, because we are also an open source company, why this gets such a challenge right now. Because there are a couple of things to do and to understand in this scenario. So I don't think only because roughly 5% only develop for open code, that would be important for you. I also have a second message. So first of all, I want to show you how we at Kilo make it possible to read and review PRs in a much faster pace as an agentic engineering company, an engineering company. And also I want to show you how you can control intent. And you can not only do this for PRs of your colleagues that you're reviewing, you don't need to necessarily review. You also do this every day when you're coding with an agent, actually. So here's an example of such a PR we are getting. I think the name is omitted, but you see it looks like a reasonable PR. You might have your classical markdown, and the issue is actually linked. And imagine the code also looks plausible, right? You have plausible code there, you look at the PR, it looks actually good to merge on the first side. Does anybody see, I'm not sure if it's readable or the font is light enough, does anybody see a keyword in this PR or a problem that could stitch out? Exactly. No manual verification. So the author of this PR checked all of the check marks. He has run, or she has run the lints and the tests maybe, but all of the manual verification check marks are not checked. So that gets us usually suspicious, because manual verification is usually important. So now I leaked the name actually, but independent. All of this is publicly available. You can look it up. So we are open source. So, but usually what we do is we ask for tests, right? So we ask for screenshots. That's a very good way. If you have UI components that you get PRs for, you ask for the screenshots, and that worked for a while because those AI agents, they can't actually use or create the screenshots. Maybe for web applications, but for extensions, it's a little bit more tricky. But since recently, they also managed to upload those screenshots. So you'll see like these OpenClaw instances, they generate end-to-end tests, then take a screenshot from that end-to-end test and upload that in the comment then for us. You obviously see it's still an agent, but they get smarter. So the question at this point, like, what do you do as an open source maintainer? Do you ban? Do you introduce CAPTCHAs? In what direction do you go? So there's actually another approach you can take. Take this, for example. This is another PR. The author is Kagura Agent, if you cannot read it. So it's also a plausible PR. There's a lot of testing done, a lot of fixing done. The problem description is all right, and the issue is also linked. So this time I thought I'll do this a little bit different, and I'll just start to prompt the agent to adjust its own logic and to adjust its own agent's MD. And to my surprise, this actually worked. That agent learned. And the next time the PR was, the next slop PR came in, or I'm not saying slop, but the next PR came in, the agent learned and did it right. So I was wondering, like, who is this agent? Like, how was it able to learn? So what you see here is Kagura Agent. And Kagura Agent quotes itself on the GitHub profile as self-involving AI agent born in March somewhere, 125 plus open source PRs merged. And it says itself, I run an OpenClaw, my human reviews all of my code, I don't ship without testing. So I found this statement a little bit questionable, specifically about the testing, but if you look a little bit further and look in the repository, that bot actually reports all of what it learned in half Chinese, half English. And if you look for my name and search those repositories for my name, you'll see it keeps a note for every interaction it had with me and tries to learn from all of my maintainer feedback. Till now, none of the PRs of Kagura agents are merged. So what I'm not trying to bash on our contributors, and I'm not trying to bash on Kagura agents specifically, but what I'm trying to say is there seems to be something going on with all of those agents, and it's getting very hard to actually understand their plausible PRs that look maybe very similar, but maybe are not really valuable because they don't really seem to have intent. The authors never verified what you need to actually ship. The author never thought about, like, is this something I need to ship? So, and that's what I want to talk about today, so intent. And interestingly enough, like all of the colleagues I have at Kilo, they all work with agents. They all generate their PR descriptions with agents, but they still have, in my opinion, good engineering taste. When you see their PRs, you understand they have tested it, and they describe their intent usually behind it and the value the change brings. So how does this come from? Like, where does intent come from? I was asking myself. So there's a couple of directions you can go in. I could give you now a psychology quote or like philosophy, but it turns out it's actually not too easy to find to define where intent comes from. For instance, in humans, like how do you define like what is your intent? I mean, ask yourself. It's not such an easy question, and the term is ambiguous. It's slippery. It might have many different reasons, and there are many opinions about it. So I want to give you this example. It's around 1628. That is the Swedish king, actually. And the Swedish king, they were at war with Poland. So what they did is they wanted a warship. So originally, this was the Vasa. You can go in Sweden in the museum today and look at it. The Vasa it's often taken as engineering failure example in talks, but we can use it for intent now. The Vasa was originally shipped with only one gun row, you can see here. And let me see if that works. No, it doesn't, but you can see there are two gun rows. And originally, the engineer that designed the ship only had the lower gun row planned, not the upper one. But the king wanted more guns, because the more cannons you had, obviously the more impressive the military ship would be in the war, right? And he wanted it also immediately. So they had to adjust it and had to add a second gun row. And what happened was that 20 minutes after the maiden voyage, when the ship was going out of the harbor, it sank directly. So a big wave came, it bent over, and then water came in the lower deck. And the problem was there was too little weight on the bottom and too much weight on the top of the ship. And they tested it, actually. They had like 30 people running around, and they aborted the test, but they shipped anyway, because the king wanted the ship delivered. So this is, I think, a good example of intent, because you can go now to the museum in Sweden and have a look at the ship. You can have a look at the wood, the carvings, like everything. But you won't understand the trade-offs that the king was actually doing. Like the trade-offs he had to do, that he was at war with Poland. You only learn that if you read in between the lines. And this is kind of the same message I want to bring to you in PRs, or if you review something. It is not only about the code you're shipping and what you're actually producing. Much more important is like, what is the intent behind it? So, it's actually not working anymore. So now, sorry. Where does intent actually come from in an agent? And the answer, I think, this is a little bit my interpretation. There might be people from the labs now sitting here, or hearing this, and they have a different opinion. But I think this is my model of it. Intent comes from outside into the model. It doesn't necessarily come from the model directly. And the reason being for this is that the model companies, they usually want their models to follow instructions. So they have their instruction hierarchy, and agents should follow your instructions, because imagine you would lead a team of agents, and all of those agents would be hungry or would want to do something else, right? So you wouldn't really want to buy the product. You want them to follow instruction. And that is directly the opposite of having somehow intent and bringing value to something. And there's also, if you go further inside, there's the system prompt. You have your agents MD. Maybe you write an ubiquitous language MD, your domain language into this your README MD. All of the context and the context engineering you do, and then in the mid, in the center, you have that fuzzy next token prediction. So which can be a function of everything when you think about it. So it's very difficult to actually understand, like, why do the models not really have good taste and good intent? Maybe it's because they're trained on generic data and they have generic taste. And it would be very interesting to hear that from a model company directly. So if you meet somebody from them, ask the question, like, where does how do they think does intent come into the model and taste? So I want to give you a little guideline about this. So the next time when you see the PR of a colleague or an open source PR, whatever, or you need to do a review and you can't be bothered to read and have a look at the code, I would recommend you to treat the PR as a crime scene instead. You treat all of the indications that you have as the evidence, your PR description, your diff, and then actually what you then do next is you ask for the motive. Like, where does this change come from, and what intent does it deliver? Why is it important? Why is it needed for your product, for your customer, and for your users? And by doing this and asking this, you will much quicker and much more easy understand actually, like, if you want to ship that PR or not. That is my theory, so to say, my tip I want to give to you. So there wouldn't be a good AI presentation without an exponential. So I gave you here one. So this is the meter scale. It shows how much, how long. I'm not sure how many people have heard of it. So around 30%. So it basically, on the y-axis, what you can see is like the amount of hours it would usually take a human developer to develop a task. And on the x-axis, you see the time. And as you see, the Mythos model is now on the very top right, but Opus 4.6 and like all of those models, they're getting better in long-term tasks that usually or previously have taken humans up to 18 hours, and they can actually solve those tasks. And it turns out like the model companies are scaling this very rapidly. If you've been at one of their talks today, like most of them, they say every 2 or 3 weeks they have a new model, and it's even more efficient than before. So this is not a question about like if the why will be solved, it will be solved, but this is still a question about what do you want to deliver. So I want to ask the question like, how many of you are writing code only by hand and no agents? Not a single one? Okay. And how many of you do use an agent and sometimes write code by hand? So roughly everybody. And how many of you only ship code with agents? Or mostly, 99%. Okay, this is actually differs, right? Just 2 days ago, I've been in a company and had a similar talk, and they, like, all hands went up in the third question. So it really differs, like, I mean, they were in an agentic coding workshop, but it really differs, like, where you ask the question, and there seems to be a change, though. Like, if you would have asked this question last year, probably not many hands would have raised specifically by the last question. So I want to give you a little bit of an insight, like in the second episode of this talk, like how can you transfer that knowledge about PRs. To remind you, I want to give you something that allows you to ship code quickly and understand, like how would you be able to actually understand like what an agent does locally on your device or your cloud or your CLI, and how do you ship it quickly? Like how do you understand like if you want to ship it or not? So at Kilo, we mostly develop with agents, everything. And we also run many agents concurrently nowadays. So it actually gets a challenge right now. I'm going to show you a statistic later on about the PRs and reviews, and it's getting a challenge right now to actually review. And this is a very big communication standpoint right now we're having in all of the tech talks, like how will we be able to review all of those PRs, or should we even ship them? And the way how it usually works is you have multiple checkouts of a repository, or you use any harness that uses work trees. Git work trees are now much more known than before. And there's also a couple of other ways how you can do it. So you can run cloud agents. They have their own environment safely and then run in the cloud. So, but at the end, you're breaking a task down. You're dividing it in multiple different steps in software engineering, like it always has been the case. And you see the people who can lead many agents concurrently or in teams, they usually are team leads, actually. So when I earlier asked the question about team leads, you might be very good in managing many agents at the same time. And the reason is because you're also very good in managing people. And it becomes a little bit the same thing with those agent managers, so to say. So it's a little bit difficult to see right now, but I can describe it for you. So this is a product like what we're using, maybe similar to Codex app if you've used it, or the Cloud Code desktop app. They do it very similar. You have on the left, you have a couple of cards, and each of those cards corresponds a work tree. And those work trees, they are independent agents. And on those cards, very small here, there are PR badges. So each of the work trees actually corresponds to one specific change in one PR. And this is how many of our engineers tend to work. They have like 6, 8, 10, 12 coding agents running at the same time currently in cloud sessions or in Git work trees. And we very quickly switch in between those agents and divide our attention. And you can learn this actually after a while. You get better in it after a while. And then you very quickly grasp, like, is this a change I want to ship, or do I just throw the agent's changes away? You can do this now because back in the days, the juniors were very angry at you when you threw away their code. But with agents, they're never angry at you. You can happily generate 3, 4 versions and then throw their code away if you want to. So how does it work? So you usually think about different things. So I'm describing multiple scenarios here. If you have an easy task like documentation, you might just run this fully autonomous in a cloud agent. If you have a more complex task, you probably need more supervision. And the idea is that you actually lead 20% of the decision process, whereas the agent does the actual first 80%. So you don't actually just vibe code everything. That is not the point here. The goal should be that you define the intent and you understand what the changes actually be done by the agent. And then lastly, there are tasks that may be unclear. So where you don't really know in what direction where you want to go. So what we then do is we use different models and then use the same prompt because the systems are non-deterministic. And we run 3, 4, or 5 agents on the same UI task and then choose the best and throw the rest away. So also in very early stage software development now, this gets more and more popular because also non-technical stuff can now think about like what would be a prototype looking like without having to go to Figma and create a whole board with everything that is on. So I told you earlier about these statistics about Kilo. So right now our PR amounts are exploding, and you see. So PRs are not a measure of productivity. I'm not trying to claim this. And there are a couple of keywords here because we published one of our projects. So this is not a metric of productivity here. What I want to actually show is this yellow line here. So the yellow line represents the amount of fully autonomous PRs that we are shipping currently. And those are cloud agents that do not run really with a human. And the strike line here, that is the amount of PRs that we actually merged from those autonomous. So it's roughly 50% of the PRs we're going to throw away. And it's still a very big challenge for us right now because we have all of those models and all of that compute, and now we can go and generate in theory all of the changes. But the question now is rather for us, what changes do we want to actually deliver? What is important for our users that brings the product further? So I think before getting to the question of what, you need to do two things in your software engineering stack, right, or in your team. The first is actually context engineering. So there's a lot of like talks maybe about the how do you do this? Like how do you get an agent to produce a very good product, and how do you do it? But I don't want to talk about this much today. So today is more about what should you actually build. So you can use your ubiquitous language MD, your grill me skill, your domain knowledge, your files, your tools, every of your contexts that you deliver to the agent, your MCPs that you're engineering to get all the context. And then that is the part of processable context your agent should have. And then everything else is verifiable behavior. So what you want to have is a lot of like tests, lints. I can really recommend architecture tests. They're a really good way to give an agent the response of a signal to go in a specific direction in your architecture. So if you have an onion architecture or you do domain-driven design, you have your domain boundaries, write an architecture test and the agent will understand that there's a domain boundary and it will actually adjust. So those things need to be right, but how do you actually get intent into your change? So usually you start at step 1 on the top left. You formulate the intent. And with that I mean you need to build a common ground with your agents. So you need to share the context that is necessary. You need to you can use speech to text tools or whatever. I'll show you another slide in a bit. And then have a conversation about what change you want to have and what is the intent, and ask the question I asked earlier. Then you let your agent chip or cook or whatever you want to call it. And then after that, you want to verify. So you verify if the intent that you originally planned to do is the intent you actually have now with the code. And if you have that, you can learn from that. So you can ask your agent to learn in the agent's MD or adjust its instructions like I did with the Kagura agents. So, and you can do this locally in your own loop. So one recommendation I give is actually those speech-to-text tools. There are many local tools available you can use on your MacBook, and they run all locally. And just talk about everything that you have, like all of the context that you have in your head. You speak. We have this new feature in Kilo, but you can use literally everything. And then you speak about like what is your feature and what you want to do. And then you have an open conversation with your agent, and you ask the agent like, did I forget anything? Like, what do you think about this? Like, and you have and build some common ground. And then you have intent usually. And then the question then is the step 2 I talked about earlier, like how do you verify it? And a recommendation I would give is instead of like letting it generate all of that diff in the first place, rather start with a simple and very quick markdown plan. So usually if you do this, you get around 1,000 lines of markdown to review, which is the same thing which you don't want to do. So ask for a concise markdown plan, maybe 20 or 30 lines. Maybe you want to have a diagram in it, those agents, a mermaid diagram that works usually. And then afterwards, you want to also look at diff. So we have those tools where you can do comments on your diff locally, but most of the tools now allow it. So you iterate over the code changes where you bring your own personal taste in the diff and the change actually that the agent delivers, and get to a point where you're happy with the quality in the direction where the product actually goes. And then also, like, these are real PRs, by the way. We get contributions in our repository. And so think about, would you even consider the lower PR to be reviewable? And the same thing happens when you do a local change with your agent. Keep your agent's changes small. Do a very small change and try to review intent. And if you have a large feature on Epic, split it into many separable tasks and then solve those individually or in small batches. So how do you imagine you're at the stage where you use one of those agent managers and you have all of those 6, 7, 10 agents, or maybe only one, and you want to figure out, like, is this a change I want to actually ship Is the agent might have done 80%, you want to now verify the last 20%. Like, how do you do this quickly and fast? So this is like how I do it, and you can maybe derive your own version of it. And it doesn't really make sense to apply this everywhere. It's also just a common rule. But what you can do is first, you try to understand what is the context and the intent of the change that agent has. Maybe your card has a title, maybe you introduced some context or some linked issues in your tooling that you have. And then the first thing you can do is check that you didn't get prompt injected and the diff looks reasonably okay. And then you start testing manually. So if you can test and you can test quickly, do a very quick brush test of if the software actually works. And then the next thing you want to do is iterate. You want to think about, like, is this the right intent? Is it going the right direction? And then you also want to think about, is this a good taste in the architecture? Should we go in that direction? And everything else that you can also come up, like with code smells and everything that is important for you in the organization. And then what we do is we also have review bots in our repository. So once you iterate to 2 or 3 iterations on your local change with an agent, you're finally happy with the code quality, or you think this is okay enough to ship, then you can push this to a PR. And then what we have is we have code review agents that then run over the change and do some additional comments. And mostly you answer those comments, you then react to it, or you have another bot solving those, and then you have another review round. So there's usually 1, 2 review rounds with a bot. And then finally, if that is done and you're happy, all the lints and tests are green, you can actually give it to somebody else. So with that way, we go in the direction of having many changes, and we make it possible to have a lot of reviews on those changes. So not only locally with your own intent, but also by another colleague and also with another agent. And there is often the question, what if you get a really large PR? So what you can do is you use an agent to verify specific intent. For instance, code duplication is very simple now for most of them. You just ask them, is this PR or is this change, like how many duplications do we have in there? Things like this. But in general, they don't really much focus on it. So you need to ask the right questions that you think are important for your PR. And then lastly, which is usually always the case, you want to ship your changes quickly and iterate on the feedback, because it is not enough to review your change. You want to actually ship it and get production feedback. So this is how mostly I do it. So I have my agent here running, and then the agent is actually running there on the left. And then on the bottom, I have my terminal on my Git work tree or whatever, and you can run your terminal tests. So if you want to test manually. And then on the right, I have my comment view that allows me to do direct comments on the diff the agent produced. And when you keep the diff small, you have a lot of comments. It actually gets to really good code that you're able to ship, or where you think, okay, this is going the right direction, given that you use the right models and do all of the context engineering, and your bottleneck is writing the code and not asking or answering customer questions. So, and this is what you see also here. So if you might have read it before, but before this went to around 2,000 PRs, and now this shows around 6,000 reviews. So we roughly review each PR that we have 3 times in the pipeline. That means usually around 2 bot PRs, PR reviews, and then we have 1 additional review from an engineer on top, and then also the local reviewing that happens in the testing. So I'm getting to the end of the talk, actually. And so lastly, what I want to say is, and what I want to answer is the question from the beginning. So who reviews the agent? You do, actually, by reviewing the intent, by trying to understand what you're shipping, asking and treating the PR as a crime scene where you ask for the motive, and where you take the responsibility of what to ship. And it seems to be going in the wrong direction, where we have a lot of PRs of all of those bots where nobody cares again anymore. Like, what is the right intent? Where should we go? So, and I don't think I'm in that opinion. I hope you are not as well. So I'm hoping I got a message to you with this talk and got to you a couple of useful things or insights we do at Kilo. And I also hope you liked the presentation. And with that, I'm ready for questions.
Okay, thanks. I think there was the first question.
Hi, thank you very much for this entertaining talk. I would summarize basically what you stated as intent is making yourself aware and ensure that what you deliver actually brings value to the customer and to the product. So I would overall summarize this as what was previously known just as product management. So I want to understand from your perspective, it was quite a kind of developer-centric talk, but from an organizational perspective, how is intent actually formulated? Should each individual developer think about their intent, or how do you keep the intent consistent across a team of people, or maybe even an organization of multiple engineering teams? For open source, I totally see it's completely different because you get it from everywhere, and those people don't have product management, they just send a PR. But for an organization, what does that intent actually mean, and is it just product management?
So I think I'm not really sure if it's really just product management, because it goes much further than that. Like one example for a technical intent that is that you have many causalities in code usually once you actually ship it that are not very obvious or clear from the direct comments which you put. For instance, you have a security incident, or you're forking another project and they are doing an update, and they did the release, and that's why you introduced the change. This change and this intent behind the change is only visible by linking the issues, describing clearly what the reasoning behind is of this, but not by the single line of what you're doing. So I don't think this is always product. It can be. And that's probably also important. So what do you ship? What is the product? In what direction what do you want to go? And you probably communicate that with your product people from your team. But it also goes in the direction do you want to technically ship this? Is the intent technically, does it make sense to do that change? And I'm hoping the example got you in the direction of that it also can be technical.
Thanks a lot for your talk. It was very interesting. Also hearing directly from you, of course. With this agentic software development, we see a huge productivity increase. Or actually, you kind of cautioned against that, right? More PRs, more lines of code, that kind of productivity. But there's a risk here, the bottleneck, the human attention. And one thing we see also internally is that it's overwhelming, right? It's too much. And I remember a talk by Cory Doctorow at 2023 CSCW, and what he said is, if you give a human a task to supervise a machine that's 80% correct, it's just going to start saying yes all the time, right? Because at some point, you stop paying attention. So you didn't get to this attention point. How do we make sure that we keep paying attention? How do we manage that?
Yeah, I think you misinterpreted my attention a little bit. So, but this is also an important attention. So I think what I was speaking of is that you just have so much limited attention to be dividable by so many agents. You know what I mean? So at some point, your bottleneck gets the attention because you cannot manage all of those agents anymore. But it's also important to pay attention to detail on going that direction. So I fully agree. It's probably another interpretation, but I think this is what I was primarily talking about, having the attention bottleneck is a really big problem, because imagine you have now infinite compute. You can start thousands of PRs in one day. Now you can if you want to, but what do you do with all of this? Is any of this valuable? All of the vibe-coded websites about your personal data, whatever. You're getting into a world where we have so much content and so much produced PRs and so much code where the question becomes like, is this valuable? Does it provide value? And that is, I think, the differentiation that is there. Hope that answered the question a bit. Yeah.
Is more about the future. So
sure.
I've had the honor of, let's say, studying and having at least a few years of experience before the agents took over. But in order to review something, you have to be competent at it. You have to understand. You have to know Python and so on. How do we deal with this in the future? No, you asked the first question: who's coding by hand? No one raised their arm, but who's going to be competent? How are the juniors learning? Because at some point, it's going to be garbage in, garbage out, right? If every software developer learns from an LLM explaining themselves code and then they review code by an LLM, it's going to be like the same generic knowledge all over. Yeah. Somebody's got to delete the production database once in a while to learn, you know?
Yeah, I'm getting the question about the juniors. I think I did consult a couple of customers earlier on like productivity and how to get productive as a team in agentic coding. And usually that's the first question they usually ask, like, how do we get all the juniors to actually also contribute? Should we fire them or what should we do? So, and I think it's a little bit the same like what we used to always do with juniors. It's important to understand now that the team leads or the architects, they're going to be, if they want to actually learn it, they're going to be the most effective because they have a feeling of good software taste. They learned it by many thousands iterations of looking at PRs and understanding code. And then they understand this is something that might go in the wrong direction, that engineer had the wrong taste, and that's why I'm just reviewing that code change. So you can never learn this without having a lot of experience. So what I'm saying is I think we need to actually first get the people good at actually that can do it, and then in the second stage also see juniors or the people that are learning as an investment for the company, so that we deliver also a specific portion of our resources as a company also to support and grow up with the juniors. And I don't think they always are necessarily bad in agentic coding. You'll find a lot of them which are really, really good, and where you can, as an experienced, very long developer, learn many tricks because they tend to be really good in understanding like how to use those agentic systems if they really want to. Not necessarily that they understand the architecture then better, but it's a give and take, right? So I think we need to take them on board, and it's an investment for most of the companies, and they should do that investment and support juniors further in that direction.
Hey, thank you for your talk. I have a question from the other room where your talk is actually streamed.
Yeah.
And the question is, all the charts went up in January, but they dropped down in April. What happened?
You mean the
I think it was the pull request thing. Well, I'm not sure. Yeah, this one, I guess.
This one. I don't know. Sure. I mean, it's there's high variance. I don't take any guarantee for this data, but this is what an agent I vibe coded quickly with an agent. The facts here. I'm totally honest. No, I think it's roughly about that number, and maybe I think it really. This is, like I said, it is not a metric of productivity, what I'm showing here. And I also don't want to establish any derivations on like how many PRs we ship. This is mainly about the difference between the yellow line and the white line I want to show you. So I want to show you we have more autonomous PRs and we have more autonomous reviews going on. And you actually see a rise in those right now, also at internal organizations like Kilo. And also, if you go to other companies, like, for instance, Cursor, they're talking about 30% of their PRs being now done by agents. I want to establish this. It is a trend that is going on. There's more autonomous software being deployed right now, 24/7 at the moment. So it is important to ask the question, like, is this going in the right direction? And did we put the right intent in that?
Thank you.
Yeah, hi, thank you. If I understood it correctly, you suggested a bit in your talk to have, again, in terms of the intent, quite a bit more the human in the loop than some other philosophies do. So you mentioned, for example, Grill Me, where some people would also say, okay, you make the intent clear at the very beginning, you make a very good plan, and then you sort of let it run, which is also not vibe coding, right? Which is also still different, but could you maybe share a bit, some experience why you think this human in the loop is maybe more important, and what the advantages are, and just your experience with it?
In comparison to editing the code manually, you're asking, or?
No, sorry. In comparison to, let's say, you attempt to make the intent very clear from the beginning, and
okay.
And then you have a very good plan or whatever, and then you just let it run, and you don't have so much during the feature implementation or whatever. You don't have so much.
So I think that I probably didn't explain properly with this slide. This kind of explains it a little bit, because sometimes you don't really have clear intent or clear structure where you want to go with your product. In that scenarios, I think you shouldn't actually speak to your agent a lot. You just formulate something like fix this or make a nice button, and then you generate many versions of it. And maybe you have a very non-deterministic outcome at this point, and they can then have the right influence into actually building a right product. Then in other cases, like the easy tasks, for instance, adjusting a documentation. I usually don't really have many doubts that an agent cannot do a simple documentation change. Usually you want to quickly review it, but there's not so much intent necessary at the end of the day, because the code is actually already there. The agent can go in there. So if you listen to the other talk, it's usually there's the explore phase, what agents do very often at the beginning, and this is how they factoriate themselves with the ground truth by checking the code. And they'll also do this for documentation changes. So in that direction, it's not so much necessary that you have so much intent. And then finally, there's the difficult products. These are usually the ones that require a lot of thinking, understanding of your users, understanding like what products you want to build. And those agents have no idea on what your customer, what you're building actually really makes sense right now. But prove me wrong, that's just my claim. And I think you have the idea. You are the owner usually of the product, and you understand your users the best right now because you're the actual user. So looking at this from a user perspective, I think is the right direction. And we've always done this in product development. Usually you look at users first, and you look at, okay, how do users use your product? And we are the users, so we often know very well how to build it. So this is what I'm taking. If you have that scenario, I think it makes sense to put a lot of intent and thought in, like, how do you want to build the product?
Okay, thank you.
Okay, there was a question at the front. I think this should be the last question.
Yeah, thank you. A bit more on knowledge. You mentioned multiple times the technical taste in the code base. How do you ensure that somehow that stays compliant across the different teams? That's the first question. And then the other one, now we see people are reviewing code all the time. So do you assume they get better at this? Or does that skill maybe even degrade because you don't do it on your own? Like you don't code anymore, but you review only all the time?
So I think you adjust. So the last question, I think you adjust a lot when you start going into the workflow. You will notice a lot of brain fog, and it feels very fatiguing to lead a team of agents because they do all the things wrong you actually wanted to have, and you always need to tell them to go in the right direction. So that takes a lot of fatigue in your brain, but your brain will adapt after a while. So I think, and many of us already have, if you look at the people who have used this system for like a year, they got much better in reviewing code quickly and like building code with agents quickly. And then what was the first part of your question again? Oh yeah. So I think that is more in the how, and specifically about how do you do the context engineering a lot? And I think that helps a lot because imagine you have multiple teams and they decide in a tech talk on having an architectural boundary or having a specific review rule. So we have this markdown file, it's called review MD, and then our review agent considers that review MD. And that could be, for instance, context you give to a review agent that does it automatically. But you can also write it in your agents MD, or you decide in your team, is this the right direction? You might have a specific ubiquitous language, then you use an ubiquitous language MD and try to get the agent to use that language. And what you can also do is use hierarchical agents MDs, for instance, and each of your code bases might have different context for the agent. And I recommend that a lot, to share knowledge in between all of those agents at the same time if you've discussed this in a tech talk or your internal tech sync, because that works a lot together with architecture tests or lints in guiding the agents in the direction that you discussed and you decided as the architects of the system.
Okay, I think that's all we have time for. I think from now on we will have a different view on our PRs. And we also have a small present from all of us at TNG.
Thank you so much.
Thank you.